Okay guys, what I'm going to do is I'm going to explain what this code here is doing and what the problem is. So what the problem is you have to add up two numbers that are coming in reverse order and return their sum. So let's just say I had the numbers, I don't know. Right, they're going to be in reverse order. So just say 1, 8, let's just say 9, 2, and then 9, 1. So these numbers are going to be coming in reverse order. They're going to go like this. It's going to be a list that looks like this. 2, and that's going to point to 9, and then we're going to have 1. It's actually pretty convenient the way they do it, because it's kind of how computers do it. All right, so what you're going to do is you're going to add these up. So we got 3. There's no carry, so that's 0. Carry plus this is 18. So we're going to, these are going to null. So we're going to stop. We're going to put the 8 there. We're going to end the loop, and we're going to say, all right, if there's a carry bit, that's what this is saying. If there's a carry bit, we're going to put the 1. And then we're going to have something that looks like this. And then we're going to return it. Okay, that's sort of what's going on here. How does this work? Well, we're going to, the important part is to understand what the dummy head is for. So the dummy head looks like this. So you're just creating a dummy head that looks like this, okay? You can put any value in here. They put 0. This is just going to null. All right. And they're saying right now, just take her. Just some reference. And you're going to point it to the dummy head. And this is dummy head. We just call it dummy. This is the dummy, right? Okay. And then we're going to carry a 0. So it's going to say, well, P isn't null or Q isn't null. So it's saying, well, either of these lists aren't null. So let's work with, I don't know. We could work with 183 plus 56. So it's going to be coming in reverse order, right? So I'll kind of write out the lists in red. Let's just do it down here. Okay, 3 is going to point to 8, which is going to point to 1, and I have 6. Now this is, you have to take into account sometimes, you know, they're in different order, right? And sometimes they're different sizes. And 6 is going to point to 5. All right. And this thing just goes to null. This thing just goes to null. Oops. No. All right. So good. Here we go. So if you're looking at this code here, we're going to say, all right, this says this. Int x equals, this says, if P doesn't equal null, give x the p-val. So let's go through this iteration here. If P doesn't equal null, we're going to use this as our list 1. So this is our P list. And this is going to be our L2. So if P doesn't equal null, which it doesn't, so we're going to go ahead and give it the p-val. All right, great. So x here is going to equal 3. And then this says if int y, if Q doesn't equal null, this is our Q list. Well, it doesn't. So we're going to give it the q-val, which is 6. Great. Okay, sum equals carry plus x plus y. Well, carry is 0. We don't have a carry right now. Probably should write it 0 plus 6 plus 3, but you get what I'm saying. The reason why they're doing this, carry is sum over 10. You don't have to do this. There's a smarter way to do this. Well, we know that given two numbers with a carry, like for example, let's say I say 9 and 9, and the carry is 18, right? And then I have 9 and 9. The carry would be 18, not 19. Given two numbers, the biggest carry could only be 1, right? Just know that. So you could actually fix this code a little bit to make it a little bit more, I don't know, a little bit more efficient. So the biggest carry you could have with two numbers is 1, right? So we're going to change this a little bit. We're going to say carry. You could change this line of code to do this. Carry, right? equals, and we could say sum greater than 9. If it is, the carry is 1. And if it isn't, the carry is 0. So you should do that. That would make more sense. This would work too, because let's say you have a carry 19. Let's say a 19, I divide it by 10. Right? And then my carry, if you get rid of the decimal, you're going to have 1, right? That's 1, that's 10, that's 9. And this is like remainder or whatever, blah, blah, blah. So it's just going to take the 1. But that's not good, because you don't need to do that. For 3 numbers you would, but for 2 numbers you don't. If you want a more general solution, I guess that would be okay. Okay, anyway, so the carry here, if we're using this, is sum greater than 9? No, so it's going to be 0. And then let's go to this one. Cur.next. Oh, carry is sum. I did that right. Cur.next is new list node. So we're going to say cur.next. So remember, cur is pointing to here. And then we're going to say cur.next. And dummy's pointing to here as well. So cur.next, we're going to get rid of this null here. Cur.next is going to be the new list node sum mod 10. So if I take 9 and I do modulus division by 10, I get a remainder of 9. So that's going to be 9. Right? And this is going to go to null. Now the next line is really important. It says cur equals cur.next. So this was here. So what we're going to do is we're going to say, all right, well, we're not here anymore. We're not here anymore. We're going to move cur to here now. Okay? And we're going to do the same thing. So let me go ahead and delete some stuff here. And we're going to go through this again. X, if we look at this list, is going to be 8. And then Y, well, it's not null, so it's going to be the value, 5. And then the carry, this sum is the sum, the carry is 0, so it'll be 0 plus 8 plus 5. That's the sum. So we get 13. Then we're going to say, we're going to use the one I had before, so the carry is going to be 1. We're going to say if it's greater than 9, the carry is 1, right? And then we're going to say the, okay, so current.next, so cur.next, so this right now is going to point to a node where the value is going to be sum mod 10. So if I take 13 divided by 10, the remainder is 3. That's like, you know, carry the 1, write the 3 down. This is going to go to null. And it's going to say cur equals cur.next, excuse me. Cur equals cur.next. So we're going to say, all right, well, cur was here. Now cur is here. Notice that dummy is still pointing here. Really important to understand that that dummy is still pointing at the head of the node, right? We haven't touched it. We're just moving cur along. So we're going to do this again, and we're going to do this for the final round here. So I'm going to just do this, and we're going to do it again. So x is, this is x. Is it null? No. So x is 1. Okay. Is q null? Well, yeah, it's null, because when we get here, it's null. So we're just going to give it the value of 0. Sum is carry, which was 1, plus x plus y, that's 2. And now we're going to say cur.next. So this right here is going to go to a new node. And that new node is going to be 2 mod 10, which is 2. And this thing is going to point to null. Okay? Yeah, so now we're going to say cur equals cur.next. So cur, let's cross this out with a different color. Now cur is here. Okay? So let's go back to the top. We're going to do another iteration. All right, is p null? What we said. Is P null? Let's see. Is P null? Yes, P is null. We got to a null value, right? All right. All right, P is null. So we're going to say, well, oh, it wasn't null actually. So we're going to go to here and we're going to go to null. Sorry about that. We're going to go to null. It was here. Now it's here. Right? This right here, these lines are advancing the lists. So this was, here, so it's not going to do anything. Now, what's happening is P and Q are both null. It's going to get to the top of this loop. It's going to say, all right, well, we're done because they're both null. And then you say if carry is greater than 0. So if we have some carry left over, what we're going to do is we're just going to simply say, all right, take this cur, point it at the carry. Biggest carry again would be 1, right? So this would now go to here, point to 1, and this will go to null. Now when you return, you're returning the dummy head.next. Now why are we doing that? Well, remember, we made a temp dummy head with 0. You don't want to return this value because it's not part of it. Dummy head.next, you're going to say that's pointing to here. So you're going to return everything from, it's a little messy, but everything from here to here. So it'll be 9, 3, 2, and if we had to carry 1. And, yep. Well, we don't have a carry, obviously, so it won't do that, but it'll just return these nodes here, and if it had a carry. So hopefully you get what this is doing. This is advancing the lists, right? That's important. That's advancing the lists. This is getting what the value of the next one is, minus the carry. This is getting the carry. There's a little bit better way to do that. This is getting our sum. And this is just doing a really clever way of saying, well, if the list is null, give it 0. If it's not null, give it the p-value. So that's it. It's a really good code there. Really nice solution. Very easy to read and really easy to understand. The main important thing is understanding what this dummy node does. You're advancing the cur node, but you're not advancing the dummy node, which helps you just return the dummy node and not reverse the list again when we're done. Otherwise, we'd have to do that. Now, it would increase the time complexity to n, which you don't want. Actually, it would be 2n, because this would be n, and then you have to go through again and do another n. So, which, it's roughly n, but this is a more efficient way to do it. Okay, thanks for watching.